Okay, so hello. So today we'll be doing differentiation, right? Last week I actually stopped at rate of change of related quantities. Okay, so I just asked like few questions about rate of change of related quantities. So like any one of you can tell me what you understand from the subtopic rate of change of related quantities. Any one of you can tell like, what you understand from the questions or anything.
Wait, rate of what again?
Rate of change of related quantity.
Which is the different? Sorry,
Yeah,
hiccups.
differentiation.
Differentiation, right?
Yes, yes.
Okay. So what I understand,
Hmm.
uh, is what we understand. I mean, like, of course, the tricky part about those sort of sorry, the tricky part about those questions is like you have to like really know what info you
Yeah,
get and then extract it out and then manipulate it. Like sometimes they might say volume is like 2 pi r, right? But then you would have to like differentiate it to make it like dv over dr,
yeah, correct.
to for you to find the next rate of something lah. Maybe they want like rate of change of something,
Yeah,
of length, right? When maybe rate of change of length when the volume is this much, then you sub in and then you get your answer lah. So
mm,
what I understand from this is, I think definitely the chain rule one, and
mm,
second is you have to be very careful lah.
yeah.
uh,
So that's about it. Yeah, that's a good example. I like the one that you said about the chain rule. That is the key about this thing
yeah,
because
yeah.
the formula actually comes from the chain rule. Yeah, basically that. So Adib, I think it's okay, like you understand also. So, where can we actually apply this chain rule actually?
Any
Any other
other topic? I
topic
mean,
you
of course,
notice?
price index, the
Yeah,
differentiation.
that's one.
You have
Yeah, I think that's it.
I mean, you have like normal fractions lah. I mean,
Yeah,
yeah. So
yeah, that's
What
basically
I
it.
mean,
What you understand from rate of change of related quantities.
oh, that one just put the formula, put this and get the marks to enough.
dude, from
Well,
what
tell
I
what you must
gave, bro,
apply.
that's so dull, man. What the hell?
Tell what you must apply to solve the questions. What is the
That
concept?
one you just have to get all the volume. You find
Mm,
anything like that. If they ask you the volume of this water, so you take count of that, and then they want you to find like radius.
mm,
So they ask the rate of change for the radius. So you must find a dr or dh, then equals to what times up, what times
yeah.
down. The
Correct. So the main thing is actually we cancel the up and down of the fractions lah. In the end, that's how we form the formula. So the formula is always changing lah, depending on what quantities we actually use lah. Okay. So let's say I ask you lah random question. What's the formula for volume of cylinder? Just in case lah.
Ardip, answer Ardip. Formula for cylinder day. Test you lah.
103 pi r square h.
What?
103 pi r square h.
3 pi?
No, not 1 over
One
3
hundred
pi r square h. No. It's not 1 over 3.
It's
It's
just
just
pi
pi
r
r
squared.
square h. Yeah. Just the
Yeah, correct.
cone only
Oh,
becomes
volume
1
of
over
cylinder.
3. Yeah.
Because
I thought volume of
cones
cone.
make up one
Sorry.
cylinder.
I had to sit
Right,
up.
cones 1 over 3. So yeah, that's the base. Sometimes the basic stuff we have to know. So we cannot start the differentiation process if we don't know that formula to start off an equation, right? The following steps cannot. You'll be wrong, like if you put a wrong formula at the start, then all the future one will go wrong. So that's the important part. And yeah, they won't give you formula of all this in the formula sheet. Of course, okay, yeah, I think that's about it for rate of change of related quantity. So now we're actually doing stationary points. So can you see what I wrote on the whiteboard?
I see some sort of moral technique.
Moral technique.
Let's be honest, bro. It looks
Not
like that,
really.
man. Okay,
Not
so
really.
I mean, we have the forest. Some dudes going up a mountain. I mean, I see
Yeah.
stickman
Okay, right.
figures.
Then
Right?
then you can see. Okay,
Uh,
explain to you like it's analogy this one about stationary
uh,
points. Okay. So now I think stationary points, or you can call this also turning points lah, the curve. This is what we learned lah. So let me see. I use this mountain for a reason lah. So if you notice this mountain, right, where is the stationary point located at?
on the very top, the like apex of the thing. Yeah.
The point here. That's why it's the stationary point. Means it's where the curve goes stationary lah, or flat basically. You can do a tangent like that. So that's when you reach at the top, you also come stationary lah. So This one is when you go up, this is when you go down. La. So just at that particular point only is a stationary point. La. If you call like this one all is not stationary point. La. This one also won't be stationary point, only at the top there, okay? So that's one of it. And about this traffic thing, so when your car go here, right, you will stop at the traffic light. So this is another analogy. La. This point is stationary point also. La. So this is why I call it stationary point. You will stop here and then you will continue your journey over here. So this is why I called it a stationary point. So yeah, this is what the diagram explains. La. So these are the two main keywords you'll actually see in your exam, la, stationary point or turning point. So other points, this one from here we can divide to two. Do you know what? If turning point you can divide into two, what are those? How do we like categorize turning points? Two types.
Yeah, why this one? Chapter. Oh,
Yeah.
the graph, this one.
That's why I draw this mountain like a quadratic one.
Oh, dy dx equals to 0.
Yeah. So
D
if you say
square dy
turning points, how many
not
we
a
have?
0, minimum point, whatever.
Yeah. Turning points, how many we have? Two types. What are the types of turning points you can tell? Based on the shape of the graph, of course. Do you know any types or not? This is the key.
Maximum, minimum.
Yeah, correct. Maximum point.
D squared or D square y over dx square more than 0 mean minimum. D square y over dx square less than 0 mean maximum.
Yeah, correct. So that is your second derivative, basically. So that will apply when it's either minimum or maximum. So this one will apply for this and this. But if I say stationary point or turning point, what is the formula?
D by dx equals 0.
Yeah, correct. It can also be d2y over dx2 is 0. You know, there's two ways based on the textbook. We actually showed this one also. But usually we will use this last, preferably dy over
I thought the
dx.
answer would be different.
Huh?
I thought the answer would be different.
It depends now what's your original equation. Let's say my original equation is 3x squared plus 8x plus 5. So let's say I do dy over dx. Let me think. I think this will apply when your equation is power 3. Because when you power 3, right, you differentiate twice what you get to your x power. Let's say the x power start with 3. You differentiate twice what is your x power now.
Oh, you differentiate twice what is your x power. I mean, you get 1 lah. I mean.
Yeah, x power 1. So from here, this is why we apply d2y dx2 is 0. Because you form linear equation, then you'll get 1x value. But if it's quadratic itself, then most likely we only need to do one-time differentiation. Because you already form a linear equation from here.
Yeah.
You can apply this one.
That's why for curve for curve graphs they usually give you the word gradient function. So gradient function is the dy over dx.
That's a very good point. So this is the keyword also in this chapter. You always say gradient function. Or maybe tangent also. Yeah, so tangent is actually a dy over dx in this chapter. Okay. So now we go to the graph itself. How we analyze the graph based on all the points. Then you'll know which one is what. So yeah, that's basically some. Then we'll try.
You said what? Tangent?
Yeah, tangent. Why?
Your tangent is your dy dx.
Yeah, correct. Why?
Yeah, correct. Sorry. I confused myself with tangent and normal.
Normal is
the what a negative one is perpendicularly to
the
tangent.
What?
No, there's a doctor in the mute.
There's a doctor. What? This hiccups is killing me. I'm dying here.
Why?
How do I stop hiccups, bro?
Oh.
You give me a maths formula, Bhuvan.
Now come, we do a complex graph now.
Okay.
I give you this shape,
This one amplitude physics one,
we're going to analyze this graph, minimum and maximum points. This is stationary points lah, basically, but I just make it more complex lah. I put many. This is a cubic graph, if you notice this shape. Then this is quadratic and quadratic. So yeah, I just combine all the graphs possible lah. I think yeah, okay lah. So now we analyze. So how many turning points can you identify from here?
1, 2, 3, 4, 5, 4.
Yeah, very good. 4. 1 is here, 2 is here, 3 is here, 4 is here. In cubic, we have, I think, 1 turning point, if I'm not mistaken, only this part. Okay, so yeah. Let me ask you one question. Let's say I sambung the graph to a linear graph like this. Do you think linear graph got turning point or not?
No, 0.
Nah, no turning point, right? Correct. Because it's already in x power 1. So this is the reason why we don't have quadratic and cubic, we have turning point. So power 2, power 3. Maximum we learn in our syllabus is power 3 only. Okay. So now we analyze one by one. This point, you think this point is what's the formula we'll use to find out?
Oh, that yeah, this one. Okay, so if wait, turning points for all or just that one point?
One only.
Oh, then you differentiate once lah.
Yeah, correct. So how
Yeah.
is this maximum or minimum?
That is this one. What's it called again? Maximum lah.
Maximum.
Sorry, minimum. My bad.
So what's the
Mabo.
formula? What's the formula to find the minimum one?
Oh, to show whether it's a minimum or maximum. Then you this one second principle or what? You 2 times you divide the x 2 times.
So less than 0 or more than 0?
If it's less than 0, it's maximum point. If it's more than 0, it's minimum point.
Correct. So easy way to remember is remember your a value in quadratic. If a is more than 0, it'll always be minimum. So that's the analogy here. So not doesn't mean it's like this, right? Just a way to remember. It doesn't mean that those two are equivalent. Okay. So how about this point on a flat line? What's the formula for the turning point? What formula?
Maximum or minimum?
Straight line like this. The point is here.
Oh, what's the formula?
Yeah, got what? What's the assumption you make?
Oh, dy dx is 0. Same gradient is 0.
This one you won't do second derivative. Because this one's straight line, right? If you remember your axis, this will be on the y-axis. This is x-axis. Here is 0. So here will be like a line. Let's say I put 3, right? So what is the equation of this line over here? If I say this projects to number 3 on the y-axis, so what will be the equation of that line?
Y is equal to 3.
Yeah, correct. So this is why they say let dy over dx is 0. Because if you differentiate a constant, you will get 0. Yeah? It correlates to this one.
But if you use a normal formula, y is equal to 9x, we all think the 1 is the gradient.
Y equals 9x.
Oh, yeah, correct. Yeah, correct. Sorry.
Okay.
So, 9 is the y-intercept.
Correct. So then how about this point? One more. This one is what's the assumption again?
Wait, for which again? I cut off for a while.
Yeah.
Okay.
What's the assumption?
Oh, was it? Wait. Because it's part of the same graph, right?
Yeah. But you can analyze it separately. Like I divide this into part 1, I divide this into part 2, this is part 3, and this is part 4. So you have 4 turning points.
So like you will get like x to the power 5 just for this. Power 5 or power 4 lah, like that. Then only you differentiate one by one, you will get
No, just this curve. Analyze this curve. What curve is this?
Oh god, excuse me. Yeah. So son, of course, a is less than 0.
Yeah, correct. So your d2y over dx2 also less than 0, no?
Yeah.
And then your dy over dx, you want to find the turning point is dy over dx is 0, no?
A is what? What is A?
A is, I'm telling you, in your quadratic form. Remember your general form of quadratic. Fx equals ax squared plus bx plus c, or A value here. It can be either more than 0 or less than 0. So if more than 0, if you remember, it will become like a smiling curve. If less than 0, it will become a crying curve. So that's why I say here it looks like this, right? This shape over here looks like this one. So this is the point here. So that's why I say it's less than 0. It's a theory, lah.
Oh,
Like when you relate this one to the quadratic chapter. This one and this one.
oh, related to the chapter 2 quadratic function.
Easier way for you to memorize what, because you might be confused. Do you put less than 0 or more than 0 for this one? So I just created a way for you to remember. Just think of your A value less than 0, so you remember the shape already naturally. Okay. So how about this graph? This point over here in your cubic function, what is the assumption?
dy dx is 0.
Yeah, that's all we can do, because this is not a maximum or minimum point. It's just on a flat line like that. Say like this, something like that. I just added on a cubic to make it more complicated. So yeah, that's about it. I think this is all about the functions. Okay. So now we'll turn it into, let me see anything else or not. Wait, I explain one thing about turning point. Let me think. First. So why, what, let me think. Why do you call it turning point actually?
Why do you call it turning point?
Why?
Is the point that takes a U-turn. So turning point.
Yeah, correct.
Wait, really? I simply you need.
No, it's correct. It changed direction. That's what I'm telling you.
Bro, are you kidding me?
In a layman's term.
What the hell, man?
Yeah.
I thought you would come out with something very sophisticated.
No, I got something sophisticated. So you say, like, sometimes when they give you motivational talks, they will say, like, blah, blah, blah.
The turning point of your life.
Correct. So why
the junction in your puny life.
So why they say it's the turning point of your life is because your life
you're gonna take a U-turn and then regress back in terms of evolution.
Yeah, correct.
What?
Because life changes, in simple words. So this is why they call it turning point of a graph. Let's say
stationary point is not turning point, right?
What?
Stationary point is not turning point, right?
It is.
Oh,
it's just stationary point, it can only be dy over dx is 0. Turning point, it can either be maximum or minimum. It can be one. Stationary point, it's always on a flat surface. So it's stationary one. If it's if it's curved, means it has to move like physics or something like that. So why I say turning point is like once we said takes a U-turn, because you see, let's say I give you a locus graph. We learned that also, so that you form something like a circle like that. So this one also definitely has turning points. What? Because the
ax cube plus bx squared some plus c, right?
Yeah, it's long. Something like this. 3x squared plus 3y squared plus 4x plus 8y plus 6 is 0. Let's say I just randomly, this is how the format will go. You'll have x squared, y squared, x and y for you to get a circle graph. So this also has turning points, but we don't see that now. The exam won't ask that. So why they call it turning point is because the shape of the graph changes. It constantly changes. The point where it changes is called turning point. That's why they say turning point. At that particular point only. So that is why they call it turning point. Stationary point means the point is stationary. It cannot move anywhere else. Okay. So this is the analogy to remember. What something was the turning point of your life. It means it changed direction. That's what it means. Okay. So this is how we want to identify turning points. So now we will go to practice. Let me see. So you can actually see your WhatsApp. Actually, I sent the question earlier. Wait, we will just practice one question on it before we move to the next one. Let me see. This one. Can see or not? We will discuss the third page there. Because the one related to turning points. So can you see your WhatsApp or not?
Yes, can see.
My WhatsApp, there's no Ronaldo.
Oh,
There's only
fastest.
Messi.
Day. Ayo, wait. I must go take my pen, calculator.
This one doesn't can need calculator.
Yeah,
But
Siri, you know, sitting next to your table, right? Where your calculator is.
always be ready with that kind of stuff. Wait, is it this one? No, yeah, this one. This one is related to the assumptions we did just now. So you just tell like one by one. First question is they ask to prove, so you say whether you can prove or not nothing else. I'll show on the board how to do.
But I come today to support you.
Yeah, so come here so to do the work.
So I give you spontaneously the answer.
First try to prove the one, number 11A.
11A. By taking the basis as shown the y is 38 of x. 9%.
You're seeing the right question, isn't it? Last page, remember?
The last one.
That's the proof P is 12x plus 750. So you just like show me your what you do on a paper like that.
Oh, senang ni.
That is considered the hardest one in this whole question. That's all easy only. And also one more tip is if you cannot solve A, right, you must proceed to the B, because the B one you can use the equation they gave you here. P is 12x plus 750 over x squared. That's the advantage of this chapter. They'll ask you show something, right? Then they'll say like find the value of x when A is least. So you can actually use the equation on top. You don't need to solve the one if you don't know. You can proceed to the next one and then continue to get your marks down there. So that's a tip also. Because they'll ask you to show, usually they'll ask to show in the first question. So then they will say from there you find the least value or max value. So it's the same assumption we make always. So definitely A is the hardest because you start with nothing.
Baseline is what? Baseline is the length only, right? And base width is just a width, right?
Yeah, normal width only, like when you have a cuboid, your length and width, all that.
Oh.
It's better if you can like draw it out, then you can imagine better. You can draw on the question paper also, and that is part of the solving process also, because you fit in the information you have.
So we can borrow eraser.
Huh? How to borrow?
Can.
Okay, I'm back. Okay.
Borrow eraser, see.
Don't have eraser to throw here on the screen.
Okay, Bowen, don't make fun, Bowen. Grab food or God.
I want to see who solve faster.
Hey, wait, I now only started,
I don't think Aldeep started yet. Did you start earlier?
I just reading only now. Oh my god, dude, it hurts, man. It hurts.
This one is section B, I think. Yeah. 10 marks worth. Actually quite good, quite generous, this 10 marks. Only the A is the toughest part, actually.
Wait, Oh my god, these hiccups is killing me, day. As X, ayyo. Okay. Base width. Yeah. lah. Extra the length of wire used. What? I'm confused.
Slowly. If Audip you get your answer already, you can put in the chat box directly.
Wire.
See the keyboard, right?
Actually, that's the answer lah. There's no answer to put in the chat box. Just whether you can show
Basically,
it.
Boon, the keyboard, right?
Yeah.
Now I'm getting confused. When they say the keyboard, right?
Given a
When
piece
you
of
see a normal
wire.
keyboard, like the
Oh, frame.
the base of the keyboard must have the same width, right?
They say it's twice the width. That statement there. And they said
Right, but like the height's not given though.
No, the height
you
is
must
not-
assume your height is a variable.
But,
That one also
the thing
variable.
about
Your base also variable.
You must form two equations so
Funny.
that you can replace the height with the x.
Oh, like that one,
Yeah.
Sugar.
Usually it's
Okay.
like that. lah.
Okay. Let me see. Same P is 12x plus 750.
First of all, you must know how many vertices you have in a cuboid. lah. That's the basic stuff.
Length of wire
Boon,
used
the
is
height they never give. They must give a variable for height.
Yeah. Usually height we use h, what? So you just put times h. lah.
Oh yeah, we give.
I'm confused. Hold up. My. Okay, so like. So there mustn't be H.
Yeah. You first try to express an equation h in terms of x, then you form another equation that helps you to find the length of wire. Then you replace the h value there with the one you expressed earlier lah, in terms of x.
Yeah, this is hard.
That's why it's the hardest one for this section.
Huh. Wait.
That's why you must always start off with the info they gave there, especially the volume they told you what is what, so you can express the formula of volume from there. Then you continue lah. After that, all algebraic only.
So what lah? 4, 5, 6, 6, 12x times 4h is how much? That is perimeter lah.
Which one?
No lah, I think I got it wrong lah.
So fast.
No lah.
You must make sure to consider all
Boon, I
the.
got the answer.
Huh?
I got the answer.
Can show your working. See whether valid or
Yeah.
not. Or you can send to me so I can see here on the phone. No need to share screen now.
I don't
Okay.
understand the question. Cuboid shaped box frame.
I can try to share Audip's working later. If you cannot solve after I share this one.
Oh god. Height.
Send to WhatsApp, Audip.
Okay.
So sometimes in the exams time, if you don't know the A, directly jump to the B and C. You can solve already, I think. Let me see. Yeah. Without the A, you can solve B and C.
Find the value of x that makes the value of
What? So short. 12x square equals. Okay. 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 Looks valid.
P is I say is the total length.
Wait, let me see whether correct or not. Yeah, accepted. Yeah, quite short and also very accurate. So,
Sandy.
Okay.
Wait, wait. I need to send to the laptop first.
P is the shortest. So wait. So means now I already have. So now I just need X.
Let me download the image first. Very short working only. You see, so you'll be surprised.
Send me first. I also don't understand the question.
Actually, it's considered quite simple. This question, it's not that hard. Maybe you're just thinking too hard.
That's why. I like burnout the day.
Wait, I download first.
Show the length of the.
I'll share screen.
Buwan, can we call Sarjana Muda and Nets?
What?
Can we call Sarjana Muda and Nets? Sorry.
Aljanam, why you want to get the award?
Wembley
Why?
Award.
Who want to give you?
Buwan, dah macam Buwan. Who will give you also?
Your mic something like not so clear.
Because I using earpod.
What?
I using earpod.
Oh, no wonder. I think now it
Come
makes
on,
sense.
laptop charging.
Chivi's voice is like more booming. Yours is like cut off a bit, like soft a bit. Okay, I show here.
Dude, send me, man.
Yeah, wait, I share screen. I show here easier. Yeah. It's quite simple also actually for you to understand. I don't know whether you can understand directly because you did
Oh,
very short.
I got 12x, but like the
other part
H,
lah.
the four heights you get 750 times x square.
Can you see the
Over
screen?
x square.
Can
Yeah,
you
yeah,
see?
yeah.
Right here.
Frame, how did
Then-
you? Wait. Ayo, wait.
Can see.
Irida. Okay, wait. 12x plus what?
4H.
I got that and then I stuck already. So your H is what?
Then from here you have to substitute this one.
So
Inside here.
H is 375 over 2x square. So
Yeah.
it means I'm just incomplete lah. I'm on the right track.
Sorry. Wait,
It's 375 and then P is
10 over 2x square.
12x times 4h.
Can understand or not?
Yeah.
10.
Can.
Yeah. So that's a simplified version of the working.
Correct
actually.
lah. For me, this one I just didn't finish it. Like I got stuck there already.
Yeah. So yeah, this is actually a good working also. So yeah, I'll show mine on the board, but a bit longer lah. Okay. Stop share. You see on the board how to. Actually, Aldeep, I think you know the cuboid vertical, right? Actually, you can do it horizontal, so it's easier to see if it's
Hey,
horizontal.
wait. I get 1500 over x squared.
Did you times correctly?
Times 4, right?
Divide 2.
Why? 2x squared. Oh, yeah, correct. I didn't write, my bad.
Yeah. So a cuboid. Let's say the cuboid is like this now. If you know horizontal view, it's easier to see actually your sides. So usually you'll have like this, right? Okay. Go here. Okay, did it go in that way? I think. Okay, let's say something like this, okay? So how you're gonna do it is, first of all, say the volume is 375, right? So that's the info we have. So from there we're gonna express something, of course. So from there you can deduce that length times width times height is 375. So they said they already gave you the assumption. If they didn't say the variables, right, like x or something, you have to make your own assumption. Let's say let x equals to the width like that. If they didn't tell that in the question, so that the teacher know where you're going. You suddenly put an x there, they don't know what is the x representing for. So this one is always an important statement line at maths. Let x equals width like that. Okay. So from there we know that length is x, is 1. Okay, length is x, huh? Okay, width is x. Usually I will say this is the length, this is the width, this is the height. So they say the width is x and the length is 2x. So height you have to put as h, you cannot do anything because later you want to express it, what? So L is 2x, width is x, this is h is 375. So 2x squared h is 375. And then you express h is 375 over x squared over 2x squared.
Bro, I need to go first.
Can
got
I'll
points.
think it's 3.
I so after I had to go no. What time? Under I 6 o'clock I had chow lah. Oh shit, my hiccups.
Okay, this here. Okay, so here right, h is
Bye, bye.
75 over 2x squared.
Boy.
Okay. So now you're the powerhouse.
Nothing for me to do today.
I'll give questions soon. So here, right. After this, what do? We have to express the length, right? So length is something like perimeter, so we give the symbol p here.
P, yeah.
Yeah.
Wow.
So you see here, right? The vertices here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. At the back also you have to see. That's why we have 12, 10. 18, huh?
The 4 times 3 lah. Finish the lah.
Yeah,
You count
I
one
know.
by one.
I count
lah.
this one. So
The two bases got 4, then got 4 lengths like that. So 4 plus 4 plus 4 is 12 lah.
Yeah, 2x times 4 plus x times 4 plus 4h. Yeah, 4 heights. 1, 2, 4. So
Yeah.
from various views. So 8x plus 4x plus 4h. So this is where you start your x.
Yeah, I got the answer already.
Yeah, I know.
Yeah.
So continue with the next one.
I doing the next one.
Uh,
But I think I may have overcomplicated it, honestly.
How can you overcomplicate the one? 2x
I have no idea, dude. I have no idea. First, I put it in terms of x first. Then I put it into the god. I put it into the p equation. Right? First, I find x first, put it into the equation. Like try to figure out h first, and then get the equation that makes p the shortest.
Yeah.
Yeah.
Why like that?
So I'm getting like square root all.
Wait. I first
Because
show
square
you.
word.
This one got 3 marks actually, so I just show where the marks coming from here. So you see here, right? If you form this one, you only get 1 mark. You form the equation from the volume, you get 1 mark. And then if you can express this
The
one.
answer showed, yeah.
Yeah, and then last one, your answer showed not 3 marks. So from here itself, we get 3 marks already out of 10.
Right.
So now we continue to the B one. B is you have to do differentiation lah. You have to apply your this thing, the one I told on stationary points.
Yeah. The P stationary points,
Yeah,
but for this diagram can me?
the concept is the same lah. You will take your what? dp over dx equals 0.
dp over dx lah. Okay,
Yeah,
then that would mean why I didn't get the answer lah.
What do you do?
I just found out x from the original, the 2x square times h that we got. Right. From there I found x, which I got like square root 375 over 2h, like too many variables, too many square roots. So like I was thinking whether it's right or
But you
not.
differentiated correctly or not?
I didn't even differentiate.
Oh, that's why.
That's the problem. I just sub like that inside. What to do, latte?
So this one, so you have to notice the keywords here sometimes. So they say value of p is shortest, right? So that should already ring something in your mind. Whenever they use the word shortest or least or maximum. So So we have one keyword, dp over dx is 0. In this case, now you have to follow the variables here, p and x.
Okay.
If you use here as L, then you will write dl over dx is 0. Same thing. So after we differentiate this, you get I arrange the equation in now I bring the x power 2 at the bottom, the top is easier, equals 0.
Yeah lah. 12 12 plus.
Yeah, I did differentiated here. Oh my god. This is the wrong 12x. So here when you differentiate x power 1, you go to the front, you minus 1, you will get 12 only. And then negative 2, you go to the front. So this one you have to minus, remember, because plus and minus, you'll minus already.
Yeah, minus 1500.
Correct. Then x power negative 3.
3.
1 is 0. So
how do you determine that it's 0?
because they say the area is the least or shortest.
The A shorter. Oh, so I can take that as maximum or minimum point lah, technically.
Yeah, basically, yeah.
Oh, right. Okay. That is
That's why
new.
so they said to you this one the question. It's a keyword lah. So if I shift this here, you will get like this 150 over x cube is 12. So 12x cube is 150. And then you will get x cube is 125. So then you know you're on the right track already lah. X is cube root 125, you will get 5. One answer only lah. So most likely you should expect whole numbers in your answers for differentiation. If you get like decimals like that, it's something wrong already. Okay?
Yeah, I got x equals to 5 and then x find p. So sub back into the equation.
Just by doing this, you get 5 marks already. Can you imagine?
That's the problem with differentiation. You don't understand, you're screwed.
Yeah. Even proving question actually should get more marks because it's more thought process. But that one they only give 3. This one itself you get 5. So it's an extra 2.
If you get 90,
Wait, let me try.
Perimeter.
P is 12, 5. Mental, no? 12 by 0 over 5 12. So P is 60 plus
30. The 750 divided 25 is 30. So 60, 30, 90 lah.
90. See, and don't forget you're doing. Okay?
Yeah, that one normal lah.
Okay.
Given
so
that.
where the marks are coming from again, differentiate. So when you apply your skill, you only get mark. Yeah. Where is it? This one. Okay. Is it this one? Yeah, this one, 1 mark. And then you equate it equals 0, you get 1 mark. This is the assumption now we make. But and then you finally get your answer here as 1 mark. See? 3 marks for this section alone.
Yeah.
And
because it's all related, right?
Yeah. So that's sometimes it's the good thing of maths. You can collect marks easily in the question that you know. You already get
that's the thing.
Like linear law also. Very easy to collect marks. So that's how you must do it.
Okay, they see RM 48.60.
So here 1 mark, here 1 mark. Here is 2 marks.
2.
So total here you get 5. Nice. So you need 8 marks in your hand out of 10.
Yeah lah.
See, it's like common sense question actually. I don't know why they put it under here, but it's just like dancing everything.
Oh, they very nice. Take photo of your face all just now.
Where? None. You can see from there.
Yeah. You accidentally took off your own face.
I could see it, that's why. It's a very short working, the last one. Shorter than Aldip's working just now.
I see.
Don't think difficult, this one. Very simple only. They just introduce the price to confuse you only.
Yeah. Wait.
2 marks only, so it's just 2 steps.
Dude, I got to go, dude. My mom calling me, but dude, finish this first. I got 48.60. Like okay, so it means 1.80 times 0.9 times 30.
Yeah.
Then you get
yeah, correct.
because we get 90 centimeter per this per, but so I mean the total cuboid, whatever shape geometrical model it is.
Yeah.
Okay, but this one should be 31 participants there. If I'm inside the 31, because
What?
if I am part of the 30 participants, I will do 2 models because that's just me.
Then you can create your own party lah.
Let's go lah. They get
Two
more
marks.
marks lah. I'll put another 2 marks for myself, man.
To
Okay,
give you
okay.
4 marks.
Okay, dey. Enjoy teaching yourself, dey. Dey, you sure got no one else to join you, is it?
Alvin got, I think he'll come.
You'll come back. Okay, dey. Sorry to leave you halfway like this. I'm sorry.
Okay.
Bye.
Yeah. So now we continue. 1 meter is RM 180. So RM 180 here is 1 meter. So now we actually notice that we already have 30 meters wire with 30 participants for this. So from here we actually got 30 participants. So we have to assume that here is only 1 participant for this price for 1 meter. So later we will times this by 30. First for 1 is this, and then we times 30 to that. So what we will do is we will take the length, because we already found in the previous question B2, P is 90 cm. So you cannot sub directly cm to here because this meter, this is cm. So 1 meter is 180. And then now you have 90 cm. So 90 cm to meter is 90 or 100 meters. So from here we count the RM. So you'll get RM 180 times 90 or 100. So from here you press your calculator, you will get RM 162. So this is per participant. And then from here, they say there's 30 participants. So we assume the rate is constant. So 1 participant, you get RM 162. So 30 participants, you will get RM 162 times 30, which will equal to RM 4860. So you should expect the value to increase because the number of participants are increasing as well. So this is your 2 marks here. So 2 marks actually will come from when you can show basically the whole thing here. This one to this one. This one is 1 mark by itself. So you can actually combine this into like one operation. And then your final mark is your final answer. So 2 marks here. So yeah, this is 10 marks for section B, basically, this question. So this part has been covered already. So we'll go to the small changes. So small changes and approximation. For small changes and approximation, we have to see the word first. For small changes and approximations, we have 2 things here. Actually, they mean the same thing, in fact. So we can see here both of these actually have a symbol of delta. So delta can be delta any quantity at the back. This is the quantity. The delta actually shows the approximation. So approximation can either be a small increase in the value of a quantity, or it can be a small decrease in the value of a quantity. So it's either increase or decrease, basically, for approximation. So from here, we can actually see that if we have a water molecule here, then it's recalling your chemistry. So if here H2O, so they always put here is partially positive. and partially negative. So this actually means slightly positive. So from here, they actually compare to a neutral condition lah. From neutral condition of H2O molecule. And this actually shows that it is slightly negative from neutral condition of H2O molecule. So this is what is being shown by the approximation. And from here, this actually comes from the first principle in differentiation, which is represented with the symbol of delta y over delta x. And you'll see a formula that this is equivalent to dy over dx. So this is how the formula comes for this chapter. So this sign actually means equivalent. It's very sign over here. So this is called equivalence. So yeah, this is the meaning of small changes and approximation. Another way to find out is through the improper fractions that give you recurring decimals. Then you round it off to a whole number basically. So let's say we got a famous fraction of 1.3333. So it looks like this. So let's say I say x is 1.33333 and you continue. So you actually want to find out that finally you should get the answer of 4 over 3. This is what we expect the answer. So how we go about this is we find where it is recurring actually. So it recurs something like around here at this point over here. So what we can do is we can times this whole thing by 10. So let's say I call this equation 1. So I 1 times 10, you will get 10x is 13.3333. So from here we can form a fraction actually. If I call this equation 2, you will take 2 minus 1, you will get 9x equals to with the calculator 13.33333 minus 1.33333, you'll get something around 11.997. 12, you can put it as 12 already. So from here, right, you will notice that 12 over 9, you can simplify it to 4 over 3. This is the answer over here. So from here, we actually get the knowledge of approximation, whereby 1.3333, you can put a stop here. Although it continues on at the back here. So continue on till infinity over here. So means rounding off is also kind of an approximation. The question will say, let's say round off the value of x to 1 decimal place, let's say. So this one is also called an approximation, 1 decimal place. Means it's not the real value, but close to it. Close to the real value. So you will get, if you round off here, you will get actually x is 1.3 as your final answer. Of course, it continues at the back. So this is actually called approximation. Approximation of x value. So this is the key to it. This is the key to approximation. So it comes from this concept. So this also comes under your indices, surds, and logs chapter, where you find out the fraction that can represent this recurring decimal actually. Okay, so now we go through these topics. So So this one is actually called small changes. So the values you'll usually be getting is decimals. It won't be between a whole number and a whole number. Let's say like 15 to 16, this is not considered approximate changes. But 15 to 15.5 is considered an approximate changes. So from here, we have to see the formula. So let's say we have an equation y equals to fx. Y equals fx. Small change in x we will use like this. Small change in x is actually called delta x. And small change in y, we will use the symbol delta y. So it depends on the quantity in the end. So if you want to find out delta y, let's say the question is you want to find out the small change in y equals to what? Let's say the question is like this. Wait, we have to make an assumption that dy over dx is equivalent to delta y over delta x. So from here, we will get, we have to shift the fractions. So this equivalent sign, we can actually, like, no need to write it. So you will get delta y is delta x times dy over dx. So this is the thing we get actually from here. So from there, we actually sub in our values one by one. So f x plus delta x will equal to y plus delta y. Means if you plus the solid x value, which is the whole number, you make it, you add a few decimals to it. Means on the y value, you have to do the same thing. Whole number to either plus or minus decimals, which is this value, delta y. So what you will get is, this will be the way we sign again, equivalent to y plus dy over dx of delta x. So actually it's the same thing, because this and this we can actually cut, and you'll actually get y plus dy. And y plus dy is actually your y plus delta y. They're actually the same thing in the end. So the conclusion is something like y plus delta y is equivalent to y plus dy, and x plus delta x is equivalent to x plus dx. Means you can see the pattern over here, right? Delta y, delta x, and dy dx. They're almost the same thing, right? So similar pattern. So this is what you can notice from small changes and approximations. So this is the pattern. So from here, we have to apply the knowledge to a question actually. So small changes and approximations, usually the question is quite short. So less marks, of course. So from here, you can see that first thing you have to know your first derivative, of course. Small changes and approximations, the knowledge you must know. You must know your first derivative in the first place, which is your dy over dx. And then you must know your knowledge of delta y and delta x. And these two will come from the formula of dy over dx is equivalent to delta y over delta x. So this is the concept here. So it's basically just multiplying fractions to one another, and then you find the variable that is wanted. Okay, so now the question is, so over here, we have the question where they gave a curve. So the curve looks like this. The curve will come around like this. The curve on respecting to the x-axis. So it's like this, like this. So here is your y, here is your x, here is 0. So what we will get is this curve will come down like this. And then this curve has the equation y equals 1 minus x squared. So it's something like a quadratic curve, but it's on the y-axis. The quadratic respecting the y-axis. Usually the quadratic we have is respecting to x-axis, means it will come like this with a normal shape. So from here they actually gave you small values or small changes, where here is p, and then here is p plus k, means they added a number. Means k is basically this gap from this point to this point is the value of k, and then they project this point to the y-axis, you get q. So there are three variables here, p, k, q. So now we're going to find the approximate changes here. The first question is simple. First derivative only. So first derivative from this equation, of course. So you will do dy over dx equals, so you have to shift this equation to a normal form, negative x squared plus 1. And then from here you do dy over dx, you will get negative 2x. So that's already your answer. Just one step. So from here you get 1 mark. Yeah, just one step for your answer. So over here is 1 mark. So total is 4 more marks left from the part 2 actually. So from here, so now the question comes, how are we going to apply the approximation knowledge to this graph? So from here, you have to make an assumption. The assumption is delta y in terms of approximate value of q in terms of p and k. So what we are expecting is the final answer will be q equals something something p and something something k. So this is what we are expecting based on the question. So from here, we actually can see we have to find out delta x. And delta x actually comes from the x-axis. Means the approximate change in the x value along the x-axis. So we will get p plus k minus p. You open the bracket, you will get k only. So this is the value here. The k value is the approximate change. And then you have to make the assumption dy over dx is delta y over delta x. So from now we can substitute the value. The earlier answer we got on top was dy over dx is negative 2x. So from here we can put this one inside here. So negative 2x equals to delta y, we don't have the value actually. Delta y is something like delta q. First put on the x on the y-axis, q is on the y-axis, so they are related. And delta x we found out here. Delta x is k. So delta y will be negative 2xk times here. So we'll get the one. And then finally we will substitute the k value with p. The x value with p, because p is on the x-axis. So you'll say at x equals to p, delta y will be negative 2pk. So we don't want the x because they want in terms of p and k only. So no x on the other side of the equation. So the equation will form is this one. Delta y is q lah. We don't use delta y. Q is y plus delta y. Means you want to see the changes over here, what it affects on the y-axis as a whole. So when we increase the value from here to here, we want to see what is the change to this q value over here. So we will get y, we got the equation earlier, 1 minus x squared. So x, you have to replace it with p already now, because x equals p. So here also the assumption is x is p. So 1 minus p squared. And then plus delta y. Delta y will be negative 2 pk. And then we will get 1 minus p squared minus 2 pk. That's the final answer. So we already fulfilled that delta q in terms of p and k. So this one can add a delta here. So delta q in terms of p and k. So only p and k on the right hand side of the equation. So here got actually 3 marks. So 3 marks will come from we use delta x is k. Means we find out this one here. 1 mark over here. And then we use the assumption that delta, this one here, is the assumption we made. So here is 1 more mark. And then of course the final answer of q is this one. Also 1 more mark. So total there's 3 marks over here. So this is the question on small changes and approximations. No? So as a whole, we have to link everything to how to see differentiation chapter as it is. No? So we see here. So differentiation is actually 4, 1, 2, 6 subtopics. So differentiation in a mind map. So of course, knowledge of differentiation can actually come from various chapters. So from here, I can say input here is quadratic, one of the chapters. I can say functions as well. I can say integration is very closely related, these two. And I think simultaneous equations also, because you have to form equations that can use substitution method. And then, of course, indices, surds, and logs also, this chapter, because of the approximation part. So this one is because of the approximate changes. Other than that, there shouldn't be any chapter. Modifying equations, normal, yeah, probably about it. So there are actually 5 chapters that actually support this differentiation chapter. So these are the 5 you need to master. 1, 2, 3, 4, 5. Okay, so differentiation itself, idea of limits is the first thing we learn. So idea of limits is one of the components. So from here, idea of limits. So on differentiation, we actually have 2 things. First derivative and first principles. So I can say they're actually equal to each other because they will get to the same answer. So this is the mind map. So from there, we actually come out with various formulas. So to apply first derivative, first principle stands on its own. So we need to know the 3 steps, which are form 2 simultaneous equation. And then you apply elimination method. And then you apply your expansion plus algebra. And then you find delta y over delta x. So from here also you must add delta y and delta x in the process of forming the simultaneous equation. So then fifth one, you will assume that your delta x go to 0, the limit. So from there you can find your dy over dx. So first derivative will be supported by two rules. Basically two rules. Quotient rule and also product rule. So these two rules can help you get your first derivative. And of course, one more is basic differentiation. Okay. So one more is just straight away you do dy over dx. So this one is basic differentiation. Okay, so product rule, quotient rule and product rule, you have to know the formulas. So let's say we use u and v. So this is the common one we'll use to assume for this and this one. So quotient rule will go like dy over dx, or you can use fy max depending on the situation. So you'll get v du over dx minus u dv over dx over v squared. So the formula is long. So this is one of it. And then product rule, the formula will be here. The product rule will be dy over dx equals u dv over dx plus v du over dx. So this can also be f prime max depending on the question. So why they call it quotient rule? It's because of the word quotient itself means divide. So if you cannot memorize the formula, you should expect that in the formula itself there should be a divide sign. So it's called quotient rule. So divide v squared. So the keyword here is divide. Something divides something. Okay. So and then product rule, why we call it product, is because let's say product of 8 and 5, you will get 40. So this means that 8 times 5 is 40. So product means times. So that's why they call it product rule, means there are times operation involved here to get your differentiation equation. So this is how you remember product rule. Product rule, the keyword is multiplication. So this is what you'll get here. So these are the supporting factors that actually give you differentiation and integration. So from here, they can also use chain rule. Chain rule will be applied in rate of changes. So first of all, from first derivative, you can actually go to second derivative also. Is the link here. So here is using d2y over dx2. So that's how we do second derivative. And then separate section, we do tangent normal. So this is the first part. Formulas covered. And then we'll continue with the chain rule. So this is how it looks like, the whole thing. So next is actually using the relationship of curve, tangent, and normal. So let's say we know a flow chart. Here is curve, here is tangent, here is normal. So we cannot jump directly from here to here or from here to here. So you have to go through 2 steps to get from curve to normal. So from curve to tangent, you'll actually do dy over dx because tangent itself is dy over dx. And then if you want to go from tangent to normal, you will apply gradient of tangent times gradient of normal is -1 because they are perpendicular. This is the theory. Perpendicular. So that's the formula for perpendicular. Means m tangent is dy over dx times m normal is -1. So your m normal will be negative dx over dy. So this is what you will get. You inverse your differentiated equation and you had a negative there. So this is what you get. So if we go opposite, the normal to tangent, let's say you do down here, curve, tangent, normal. So you want to go this way. If normal, you already have the equation, and then you want to go to tangent. Means we still apply the perpendicular theory, just that now we want to find m tangent. So m tangent will be -1 over your m normal. And we know your m normal is negative dx over dy. So you will get as dy over dx in the end. When you inverse the fraction. So this is when you go from normal to tangent. And then tangent to curve, this is where we apply the integration concept because tangent is usually a straight line, which means linear equation y equals mx plus b. So if you want to integrate that, your curve will be a quadratic because the variable must be power 2. When you integrate 1 to power 2, means you 1 plus 1, you get 2 power 2 on your x variable. So you will do integration, indefinite integral here. Indefinite integral, so let's say like this, indefinite integral of dy over dx with respect to dx. So there's no limits at the bottom here because it's indefinite integral. So from here you need to plus c, and then you can find out the equation. So you have the point you substitute here will be where the tangent intersects the curve. No? That's how you can find your c. That is the point. So yeah, this is how curve, tangent, and normal are related. So basically, it's opposite to each other. You can see that. So from here, we can actually draw another diagram also to see it. So let's say I have a curve. Quadratic would be the best actually to represent it. So let's say we have a circle. Or better, a hard equation of the left hand. So let's say x, y, 0. So let's say it's like this. So let's say I put the tangent down here at this point of the heart. So this is your tangent, and then your normal will be 90 degrees to the tangent, perpendicular. So this is your curve. And then this is your tangent. And this is your normal. So this is how they are related in one graph itself. So yeah. So if you want to see the formula, tangent, you will do f prime a. A is like your x one. Tangent will be f prime a, y minus f prime a means you will differentiate the equation. F prime a, x minus a. Means you have to minus the x power by 1. Okay. So if normal means it's inverse of this one. Normal you will get -1 over f prime a and also x minus a. So yeah. So it's basically opposite of this because this times this you get -1 times together your product will be -1 in tangent and normal. So yeah, this is how they are related. So next one, we can actually combine rate of changes and approximate change because they're actually the same thing. So rate of changes and also stationary points also can. Let's say we do one graph, one shot to show everything. Let's say it's like this. We have a cubic equation going like this. And let's say we have a straight line here. And then we continue it to a quadratic curve. And then from here, I draw a circle. So this is how we can relate all this. Let's say the circle, we draw a semicircle. It's not a fully a circle, it's a semicircle, okay? So let's say stationary points. Here we can notice 1 point. 1 point, and then here we can see another point. And then, yeah, this is just a circle, semicircle. It's to show the rate of change. So this point will be dy over dx equals to 0 because it's on a flat surface. This point, minimum point. So d2y over dx2 more than 0. Or you can also say dy over dx is 0 if you want to find that point. And then you will determine it, only we will use this formula. So yeah, this is the 2 points we learned. Let's say I just put another one up here. Here will be a maximum point. This is max point. And then this will be d2y over dx2 less than 0. And also dy over dx is 0, one shot. And here also can be d2y over dx2 is 0. But we want this one, usually, first one. Okay. So from here, we can actually see rate of change itself. Let's say I make this line a bit straight. So this is the radius of the semicircle. Radius, here also is radius. And then you will divide it like this. So the radius will spin, and then all the while when it spins, it gets the same length because it's the radius. So rate of change of related quantity. Let's say we want to see the area of semicircle. Area of semicircle is half pi r squared. Half area of circle. So it's half pi r squared. So this one is representing this part over here. This semicircle region over here. So first thing is rate of change of related quantity. So that's why it's related. The area and the radius are related to each other and they are directly proportional. Because if the radius increases, naturally the area also should increase. So they are related quantities. So if we see, right, let's say we want to find the change rate of change of area. So how we do it is dA over dr times dr over dp. because you cut off the dl and then you can find the rate of change of area. So yeah, basically this one, if you want to find this part here, rate of change of area with respect to the radius, we will get dA over dr is pi r. And then you can substitute your r value. Let's say r equals 3. You will get dA over dr is 3 pi. So here we will get 3 pi. And then the rate of change of radius. Let's say this one decreases by 3 cm per second. So it will be negative 3 cm s negative 1. So what you'll get is negative 5. This one is in cm square because it's in cm because area is cm square, radius is cm. So cm square, you divide cm, you will get cm power 1, which is cm. Cm power 1, rn power 1 is rn. So this one you will get negative 9 pi. So the unit will be cm square per second. So this is the rate of change of related quantities in a diagram itself. So yeah, this is how it looks like. And then approximate changes can also be seen here. Let's say I tell you from here, the radius increases by, let's say, 0.02 cm. So we already have our dA over dr here. And all we need to do is, let's say I decrease from 2 cm to 1.98 cm. I give the value. So the delta R we can find from here because radius increases, what? So let's say I do here 2.02, not 1.08, 2.02. So delta R will be 2.02 minus 2. You will get plus 0.02. And then you have to substitute your original radius into this formula here. So you will get here dA over dr is pi bracket 2. Means is 2 pi. So now they will, let's say you want to find the approx change in area. So how we're going to find it is delta A over delta R is dA over dr. So delta A is our unknown. And then delta R is 0.02. And our dA over dr, we already found it. It was, where is it? 2 pi, because from 2 cm. So you will get delta A is 2 times 0.02. So let's try 2 times 0.02. You will get 0.045. And don't forget the unit, cm squared. So this is your answer. All of the things has been related in one diagram, from the stationary point to the rate of change of related quantity and also approx change, just in one diagram like that. So you can see from here. Okay, so yeah, this is about it for differentiation chapter done already. So it looks like this. So the solutions I will share later. So yeah, we can dismiss already now. So let me see. I will share the how we actually solve the questions also later, and then we can compare the solutions one by one for each question. Okay. So yeah. Okay. So yeah, that's it. Thank you.